Hey everybody, today it's me and Luna the Math Cat are here to talk about box and whisker plots. Alright, this is our last sixth grade lesson of the year. So, what's a box and whisker plot? Well, a box and whisker plot represents a data set along a number line by using a minimum value and the quartiles of the data. Box and whisker plot shows the variability of a data set. It also uses a 5-number summary of the data set. These 5 numbers are the minimum, the first quartile, the second quartile, the third quartile, and the fourth quartile, which is sometimes called the maximum value. Okay, so here we have a box and whisker plot. Okay, so these are called your whiskers, right? These are your whiskers, right, Luna? And this is called the box. Now, what this represents is this represents 25% of the data, this represents 25% of the data, this represents 25% of the data, and this represents 25% of the data. Okay? So, your Q2, which is usually the one that I find first, is the median. So you put your data in order from smallest to largest, and you find the middle of it, and that is Q2. Okay? Then you take the bottom half of the data and you find the median of that. That's the first quartile. The very smallest number is called the minimum value. Then we take the top half of the data, we find the median of that. That's the third quartile. And then the biggest number is called Q4. That's the maximum value. Okay? Now this right here between the third and the first quartile is called the interquartile range. And we will use that a little bit later. Okay? So the middle 50% of your data is in the box. Your top 25% is in this whisker, and your bottom 25% is in the other whisker. Okay. There we go. So that's what a box and whisker plot is. So here we're going to make a box and whisker plot for the ages and years of the spider monkeys at the zoo. Here we got some nice little spider monkeys right here. Just so happens that I have a number line. Okay, and the first thing that we want to do is we should always put our data in order from smallest to largest. So right here, 14, that's the smallest one. And I'll cross them off as I go so that I know that I didn't skip one. 15 would be the next one. Looks like 20 is the next one. 26, 27. Looks like there's 1, 2, 3 30s. 1, 2, 3. There's a 33, a 35, and a 36 and a 38. Okay, so I kind of ran along right here. Let's move this down there. All right, very nice. Okay, so here's my data. Now, how many data points are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. Okay, that means if I find Q2, it's going to be in the middle. It's going to be between the 6th and 7th ones. So 1, 2, 3, 4, 5, 6, 7. It's going to be between those two, which since they're both 30, it's just going to be 30. So I'm going to go over here, and I'm going to put a bar right there. So that's Q2. That's my median. That means that half of the data is going to be below that, and the other half is going to be above that. Okay, now I'm going to take the bottom half of my data. That's going to be these right here, and there's 2, 4, 6 in there. I got to find the middle of that. That's going to be between those two. So, since they're not the same number, I'm going to take the two numbers, add them together, and divide by 2. So that's going to come out to be 23. That's Q1. Okay, so I'll go put a nice bar right here at 23, excuse me. Okay, now this might get in the way a little bit, so we're going to take this And I'm going to kind of shrink this up here a little bit like that. Okay. Now we're going to take the top half of the data. That would be this. Oops. What did I just do? Oh, I turned that orange. Okay. I want this to be blue. Here, let's do this. Let's move this down. Move this down. What was this? This was 30. Move that down. There we go. Now we can make this a little bit bigger again. All right, a little bit more readable now. Okay, so I'm going to take the top half of the data. That would be this. I'm going to find the middle. It's going to be between those two right there. So I'm going to take 33 plus 35 divided by 2. It's going to be 68. Divided by 2 is going to be 34. That's going to be Q3. So I go over here to Q, or 34, and I put a bar right there. Now, here's the box part of my box and whisker plot. Okay, now the highest point is the maximum. Okay, that's this one. That's Q4, or the max. Okay, so I'm going to put a dot at 38 right here, and I'm going to connect that with a whisker, just like that. Then I'm going to go find my minimum. This right here is my minimum. That's 14. That's going to be way over here. And I'm going to connect that with another whisker. There's my box and whisker plot. Okay, so it kind of shows me what the data looks like. Here's 25% of the data is stretched out in here. 25 is here, 25 is here, and 25 is here. Since this is denser, that means these monkeys over here are closer in age than these down here. These are further spread apart. Okay. There we go, we're done. Okay, this box and whisker plot shows the body mass index, or the BMI, of a 6th grade math class. Okay, so my minimum is 17% body fat, or actually 17 BMI. My high is 28. The middle one is 21. The third quartile is 22, and the first quartile is 19. So what fraction of students have a BMI of at least 22? So that's going to be this group right here. And that's going to be 25%. Okay, because remember, there's 25% here, there's 25% here, there's 25% here, and there's 25% here. Okay, are the data more spread out below the first quartile or above the third quartile? Well, obviously, this is longer, it's more spread out. So the answer to that is going to be above the third quartile. And it asks you, how do you know? Because that whisker is longer. So it's more spread out. Okay, find and interpret the interquartile range. So the interquartile range is going to be that distance right there. So it's going to be, we call it the IQR. That's going to be 22 minus 19, which is 3. That's the interquartile range. Now, what is that? It says to interpret it. What does that mean? That means that 50% of the data is between 19 and 22 inclusive. Now, inclusive means that 19 and 22 are included in the answers. So there could be numbers on here, and there could be data's right here, and anything in between them. Alrighty. So here we have a double box and whisker plot representing the prices of snowboards at 2 stores. Identify the shape of each distribution. Okay, so if I look at store A, the shape is pretty symmetric. I mean, this and this are about the same. So is this. This is a little bit longer. But I would say that it's fairly symmetric. Or you could say that it's slightly skewed to the left. And it's slight. I mean, there's not much more here than there is here. Okay, now if we look at store B, that is not symmetric. That is definitely skewed to the right. It's got a tail out here. Most of the data is on this side, so it's definitely skewed to the right. Which store's price is more spread out? Explain that. Well, okay, obviously it's the store B. So now why? Well, first of all, the range, which is the distance between the minimum and the maximum, is bigger. So we would say that's the best way to say it. So the range is, in this case, 650 minus 250, which equals 400, okay, for store B. Now, store A, the range is going to be 450 minus 150. So its range is only 300. Okay, so this one is definitely more spread out. Oops. Can't write today. More spread out. Okay. So there we go. You get to do problems 1 through 29 odd. I'll see you guys later.